On track. Okay, so I'm talking about the exam. So we will be doing the exam week 8, which is March 10th. You will, the exam is going to be posted probably a few hours before the class actually begins. And at the very top of the exam, you'll see my phone number, which you guys have already. But if you have any questions or something comes up and you're like, what does she mean by this? Like, feel free to shoot me a text. And whatever question you would usually ask a professor in class during an exam, feel free to do that. That's very appropriate. Now, if you ask me, what is the answer to number 3? I'm not going to give you that. But if you're like, I'm overthinking this, I think I'm really struggling. Can you, I'm happy to be a sounding board for you guys on that. The goal is not for the exam to take you very long. Like an hour should be sufficient. And if you guys need additional time, obviously let me know. I'm not going to close it out till midnight that night anyway. So you do have some wiggle room with that. But if for some reason something catastrophic happens or you're just not feeling well, please just let's have open communication so we can figure that out together. Okay. And the exam is going to cover everything up to the exam week. So if you look through here, this is our textbook. You go up through chapter 6 is what it'll contain. Now, I'm putting a little asterisk next to that simply because it is week 5 this week. So we still have 2 more weeks of content. And I just want to give us some wiggle room. So if something happens or we don't quite wrap up a lecture, we'll adjust accordingly. So stay tuned. I'll give you guys more info in the following weeks too. But any questions aside from that on the exam? Okay, so that was my let's catch up and make sure we're all on the same page little announcement. So I feel we ought to start by discussing the lab. So let's open this guy up. Okay, let me just share my screen so you guys know exactly where I'm at. This is our Course Connect page, right? So if you click on Lab 1, you'll get an Excel spreadsheet. You can open that up. You guys probably can't see it now though, right? Do you see the Excel spreadsheet?
Yeah, it's there.
Oh, you do? Okay. Occasionally it's weird if I like launch another program, I won't see it. So the goal of this exercise is to see, it's a frequency or descriptive statistic analysis to see if there's a difference between levels of education, which is this qual race here, and sex and race. Okay, so before we move into that, let's do a quick step back into the code book. Can you guys see the code book here? Did that open as well? Yes. Okay. So sex in this specific survey, this is the General Social Survey of 2012. The item that they utilized back in 2012 for sex was 1 is male and 2 is female. So that's how it's coded. Note that there's like 1,974 participant entries. So we have a lot of data. So for the specific variable of sex, your options were 1 and 2, right? If you see a 1, that means male. If you see a 2, that means female. Qual right here is the variable that displays the respondent's highest level of education. And here is that's how they decided to split it up. So if they have limited high school, they received a score of 0. I'm saying score. That's not what I mean, not in that sense, but like that's the code of it. If they completed high school, they are noted as a 1. If they went through some junior college, they have a 2. If they have a bachelor's degree, they have a 3, and graduate school, they have a 4. So that is ordinal data, right? It's not like from a 1 to a 2, it's doubly better, right? Or 2 to a 4 is not doubly better. So it's not an interval ratio item, it's an ordinal item. And then lastly, they identified race by 3 specific categories. So if an individual identified as white, they put a 1, black 2, and other 3. Now, this is a limited data set. I could spend an entire class talking about how not ideal these classifications are. But that's beyond the scope. Once we get to research methods, we will dive into all of that. Really what we're looking for here is the meat of what is the findings. So going back to, whoops, that's not what I want. Going back to Course Connect right here. If you look at the Lab 1 assignment, you will see these are your instructions right up here, okay? It says copy and paste the pivot table into a new document and include 2 to 3 sentences of interpretation for each analysis. Submit by next week's class. I did not do my best job at describing this, but this is why we spend part of the class lesson discussing it. So in order to figure out where people fall, which category or box they fall in, because my question again is education different for men and women, and is it different for different racial groups, right? That's part of my question. In order to do that in Excel, we will use a pivot table, okay? And once you gather your pivot table, you will copy it, paste it into a Word document so that I can see it, and you will write then 2 to 3 sentences of interpretation that describes what is it that the pivot table means, right? So you can describe in this particular group, it shows that women tend to have, there's more women that have limited high school than the men. I'm just gonna make stuff up. So you can describe part of what you noticed in the pivot table. So in class right now, we are gonna work on doing the pivot table for sex and qual. And when you guys go home later on, or well, you are home, this is weird, but later on before next week, you need to rerun that analysis, copy and paste the pivot table that you get for sex and qual, and then do it again on your own for qual and race, okay? And then copy that pivot table with 2 to 3 sentences of interpretation. So in other words, what you are submitting to me is one document that will have a table, a little bit of interpretation, a table, and a little bit of interpretation, okay? 2 separate analyses. One that we did together in class today. So that one should be easy peasy, but then you need to redo it, switching one variable. Okay, are we all on the same page? Okay. So if I go back to my spreadsheet, can everybody see the Excel spreadsheet? Okay, how many people have done pivot tables before? No, okay, well, that's exciting. So first off, my version of Excel may be different than yours. Perhaps you're like, I don't have Excel. I am dealing with Google Sheets, or I'm dealing with, I think it's Numbers, the Mac version of it. I am no tech guru. I am many things, but that is not one thing that I am. So if you're not sure on how to do it with your version of either Excel or another program, the wonderful thing is you can Google it or even go on YouTube and it'll show you directly point and click how to do it on your own. Because if you have even a slightly different version of Excel, the buttons may be in different spots for you. So I'm hoping this will be helpful, but you may still have questions at the end of the class. Okay, so first thing is you want your data set open. As you can see, sex ranges from 1s and 2s, quals go from 1 all the way through 4, and race goes 1 through 3. And then again, in terms of participant number, like how many people are in our data set, you see this is a very small bar. If I were to scroll it all the way down here, I want to say it was 1974, but now it could be wrong. Oh, see, I am wrong. No, 1974. That's right. Okay. So large data set. So to run the pivot table, go to Insert, click that, and you see right here, this very first button is called Pivot Table. So you're going to click that, and you're going to get this data range. Now, this is where you select which variable you are interested in, okay? Now, for my first analysis, I just want sex and qual. Those are the 2 I want to use. So I highlighted those 2. And this says that whatever my results are going to be, it's going to put it on an existing worksheet, just in a different location. Sorry, my cat just jumped right in my cubbies behind me. Freaked me out. All right. So you're running this, you're picking your variables, you're pressing OK. Everybody still seeing what I'm doing? Please turn your volume on if you're like, wait, what? What did you do? I want to make sure that I can catch it now before we get too far. Okay. Okay. Next, I'm going to create columns and rows where I want the data to populate so that I'm sorting my data. If you think about it, okay, pen. No, I'll use one of these. You are creating a Venn diagram, right? You're saying this is sex, this is education, but specifically I want to go, if this was male and this was high school, what is the number of people that are in this section, in that segment? Okay. So that's what I'm doing. I'm looking at where it falls in common between the two. So first thing I need to do is I need to click them so that they populate. Okay. And I don't know now where my table went. Did it go at the very bottom? Sure did. That's annoying. So find where your table is. Mine is somehow doing it at the bottom. And then I want to actually put this here. I'm going to grab these and actually move it over. And then I want to do count, not sum. Okay, I'm doing this quickly. Let me just make sure this works. It does. And now I'm going to explain it because I probably moved too quickly for the most of you. So what we saw first off is that this table to the side popped up. Both of our variables showed up as options. First thing you need to do is click them so that the data will be included for each. Once you click them, you will get usually right here at the bottom, it'll say sum of some value here. This is the biggest error because did you see, let me switch it again so you guys can see. If I go to value field settings, the default is sum. Okay, that's the default. So let me do that so you guys can see what it looks like. So the numbers are correct right here. These are accurate, but then it adds them all up. It becomes summative. I don't want that. I want a count. I want a frequency table. Okay, which is why the first red flag you should get is, I know I have 1,974 participants. How is it possible that my grand total is 3,160, right? First red flag, that doesn't add up. So go back over here, go value field settings and move it to count and press OK. And you end up at 1974. Okay. Now, this table is somewhat helpful, but I need to go back to my code book so that I remember what each of these rows actually means, right? We know that this is limited high school and 4 is going to be graduate school, like graduate and above. And then I think 1 was men and 2 was women. So based on this table, what might you glean from it? What information does it communicate to you about the relationship of sex and educational level?
Women tend to be more educated.
Okay, and in what way did you come to that conclusion?
Because the second row is women and all the numbers are higher for education all the way through than men.
Okay, so that what might be another hypothesis as to why those, because you're right, Camilla, you're right on the right track. The numbers are higher for every single domain. But then there's another big piece, which is this number here. What does this tell us?
Is it the total like women that were in the survey?
And what do we notice about that, Hannah?
There's a lot more than there are men in the survey.
Right, so we have about 200 more women than we have men. So divided by 5 categories, that means about 40 more in each, which is about what we see actually.
I have a question.
Yeah.
So I'm on numbers and it won't let me do the pivot table.
On numbers.
Yeah.
So what you will need to do, and this is just me being super honest, Grace.
Okay.
Okay, this is our YouTube page. Let's see. How to do a pivot table on number or in numbers, I guess. Okay, so I just Googled on YouTube, or I YouTubed, not Googled. Words are hard. How to make pivot tables in numbers. And you see how I have multiple results here that show you exactly that. Take a peek at how it shows you how to do it from Mac. It says, while there's no pivot table function in numbers, you can simulate the most common use of pivot tables. So it seems like maybe they call it something else. Do you see that, Grace?
Yeah. Thank you.
Okay. Alternatively, I have known that students have been able to get Google Sheets maybe on there, even on a Mac. So I would look maybe if there's another option for you to use, if that's going to be a little easier. How does that sound?
It sounds good. Thank you.
Okay. All right. So that is how you run the analysis. So what you would then do is you would highlight this table, right? You would just copy it and then put it in a Word document so that you can add your sentences of interpretation. So you might want to start looking and notice that proportionally, the levels of bachelor's degree, those numbers here, bachelor and graduate level, are almost equal, despite the fact that there are more women. So what might that mean, right? What could we see with that? So again, you're just providing some information based on the data that's provided here. Okay, so what you would do then is you would copy this table over, right? Do copy, put it in Word or some sort of Word-like document, write your 2 to 3 sentences of interpretation, and you would run this entire thing again, but instead of doing sex and qual, you'll do qual and race. And you'll do the exact same thing in here. Okay? Any questions about that?
So are we only doing qual and race then for the lab?
You need to do both. So you need to copy over your results from this first analysis and write your 2 to 3 sentences of interpretation. And then you need to run the analysis again between qual and race.
Okay, thank you.
No problem. Okay, so what you are submitting to me by next week is going to be that Word document that has both tables and both sets of interpretation. Good to go? Okay, hopefully watching this video again will help, and you can just pause if I was going too quickly and you can walk it through again. All right, I'm going to minimize this here so it's not in my way. Okay, and now I want this open. All right, where? I tell you, Zoom does not like me, gang. I need to have this open and somehow it's not letting me. There it is. Okay. Part of my problem, as my husband likes to tell me, is that I keep too many windows open on both of my screens. So it's always searching, which one do you want to share? Okay. So what we're going to talk about tonight is measures of variability. So last week we talked about measures of central tendency, which meant what? What is a measure of central tendency? What do we think? Mean, median, and mode. Absolutely. Well done, Mallory. So yes, a measure of central tendency is measuring where things clump up together in the middle or in the center or around the average, right? So that is important information for us to have, specifically when you're looking at a lot of data, you want to know what is your mean. But in the same breath, we also want to know how much does the data vary, because that will imply or impact how much stock I put into my measure of central tendency, okay? If you are a student in this class and you're like, woohoo, just got my test score back and I got a 95, and then you find out the mean was 90, right? Still pretty good, but that the standard deviation was 0.5, very, 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 very little. That means almost all of the data hung together, was very, very close. There was not a whole lot of variability. So then you might go, oh, well, actually my score is quite good then, because if I got 5 points above and the standard deviation was only less than a point, I did really well. Conversely, if you're thinking, well, you know, here's my score and the standard deviation is 25, right? Well, it shows that there was a ton of variability in the scores. So then you make different meaning out of that too. So the measure of variability is very important when we're interpreting data, okay? So the goal for tonight is going to be to explain the importance as to why we measure variability. We're going to calculate and interpret measures of variability, and we will identify relative strengths and weaknesses of the measure. And I have a barking dog, so I'm going to let him out real fast. So that is the goal for this evening. This is going to be one of the classes where we do a little bit more math, because I'll teach you guys how to do the standard deviation by hand. And then moving forward, then for labs, I'll show you the easy way to do it. Okay, so just a quick reminder, central tendency, again, it's the numbers that describe what is typical or average, or in other words, central in a distribution. A measure of variability, on the other hand, describes the diversity or variability within that distribution, okay? So what is typical, what is average? That's your central tendency. Your measure of variability is how much does it differ from that central tendency? How much does it vary altogether? He's gonna lose his mind. There's a bunch of deer in our backyard. All right. So why do we care about that? Why do we measure variability? So there's two types of measures that help us to sum up the distribution of scores without looking at each and every single score. So the first one is the measure of central tendency, like the mean, and it tells you about the typical score. The second one is the measure of variation, which reveals how far from the typical or central score does the distribution tend to vary, okay? So both tell us in a very quick snapshot what is to be expected, right? Where do most scores lie? And then how much do they vary away from that mean? Okay, so here we have a distribution of grades for a class. Note that the mean, or the central tendency, is it the same or different for these two distributions, for these two professors? What do you think?
It's the same.
It is the same. How did you figure that out, Diana?
Because both of them are, even though like the height is different, they both lie on the same like midpoint, I guess, if that makes sense.
It does. You're absolutely right. So the point or the score with the highest level of frequency is the same for both, right? Or it's the same idea, right? Like the midpoint is the same, all right? So the score is like, what is that? C plus sort of, right? So, but the distributions are different. You can see here this, I think this is Professor Yamato, has a really flat curve here at the beginning. So the number of students who got a C minus or less was 20 or so or less. And then as you can see, similarly, students who got B's or higher was 20 or so. I'm gonna let him in because he's driving me bananas. Hey. There's actually no deer, you guys. I don't even know what he's barking at, but he's going crazy. Time to call the big guns. I'm gonna have my son go get him because you guys can hear him bark, right? Super annoying. All right. So, measure of central tendency in this case is the same, but my measure of variability is very different. The spread where the data finds itself is very different. If you look here for Professor Brown, what was the lowest score in Professor Brown's class?
Straight
C
F.
minus.
Did someone say C minus?
I did.
Yeah, Professor Brown's lowest score, that's a little, diamond shape here, was a C minus. Professor Yamato's lowest score was an F. So the range of scores for the two professors varied significantly, with Professor Brown ranging from a C minus to a B, whereas Professor Yamato had Fs all throughout an A. I don't know. If you're a student in either one of those classes, which class would you rather be?
Might as well risk it for the biscuit and go with Yamato.
Like, might as well. You have a shot on an A, I suppose. But your chance of an A, I'm estimating here, but it looks like maybe there's 2 students that got an A, maybe another, 5 students that got an A minus. So, a small number, but you still have a shot of getting an A, whereas the distribution here for Professor Brown is much tighter, right? So it's all hanging together. So see how, even though the mean is the same, these are 2 very different stories as to how students are doing in the class. Does that make sense? Okay. Again, if 2 different graduate programs have an average student age of 25 and one university has a greater variability than the other, what would that mean? What do you guys think? So they have the same average. Both programs, average age is 25, but one university has greater variability than the other. What does that mean?
One has more students that are not 25 than the other, or like different ages.
Okay, you're on the right track, and I didn't get to see who that was. Sorry about that. Camilla? Are you- Okay, good. Anybody else have any thoughts about that? He is. Oh, settle. No. We're settling. All right, so what do we think? All right, greater variability. Camilla was very much on the right track. If the average age for one graduate program is 25, but the bulk are between 22 and 28, that looks different than an average age of 25, but the range is 22 to 71, right? That's a much greater variability than the one that's 22 to 28. Big difference there. The mean is the same, but what's happening is you have a much larger range of possible scores. That's the biggest difference, okay? I don't know what is going on. Okay. All right. Oh man, it's rough go tonight. Back. All right. Does that make sense, guys? Okay. Different variability. Okay. Another way that you can measure variability is through the index of qualitative variation. Now, This is just for your own edification. We are probably not going to do scores on that, but I just want you guys to understand the difference. So this is how you would measure variability for nominal variables, okay? So this would be, for instance, ethnicity or political affiliation, political preference, right? These are nominal data. You're not taking a measurement of it. You're not taking a survey and asking them for how they feel about it. It's nominal data, right? So it's not numbers. It's going to be labels. So it is based on the ratio of the total number of differences in the distribution to the maximum number of possible differences within the same distribution. It's a big mouthful. It's easier to just see it in numbers. Again, you guys will not be asked to do this. This is just so you understand, because usually students are like, numbers, I'm melting, it's scary. It's not scary, it's all right. Okay, so this is the index of qualitative variation. You would take K, which is the number of categories, okay? And then you do this calculation. It's 100 squared minus the sum of all squared percentages of the distribution, okay? Divided by 100 squared times the number of categories minus 1. Okay, what does that look like and why do we care? I've got my other dog hiding by my feet. I don't know what's going on, guys. Okay, so the top 5 racial and ethnic groups for 2 states by percentages. Okay, these are the 2 states, Maine and Hawaii. These are the main racial and ethnic groups. So we've got white, Latino, Asian, Native American or Pacific Islander, and other. And then you see the percentages breakdown in terms of race for both of those states. So this is the number of categories, right? We have 5 categories. Okay, if we go back over here, number of categories. And then the sum of all squared percentages in the distribution is what we'll need to do, okay? So that's how you would take each one, square it. I'll show you in a second. All right. So I feel like I should switch these slides around. Let me just show you real quick what it looks like. So these are the same numbers we had just a second ago, right? These are the percentages. These are the percentages squared. And this is the total percentages squared. These 2 values right here. Okay, I'm going to flip back real quick to our formula. Hang on tight, no whiplash. Here we are. Okay, so again, this is my formula. I want to know the number of categories, and then I multiply that by 100 squared minus the sum of all squared percentages in the distribution. So this would be 5, right? There's 5 categories. 100 squared minus, let me go fast, this value here, okay? Divided, as we saw over here, divided by 100 squared times the number of categories minus 1, which would be what? Number of total categories was what?
5.
5. So 5 minus 1, 4. Okay, so that's my formula. This is my initial frequency. Let's read about this slide real quick. The index of qualitative variation is a single number that expresses the diversity of a distribution. It ranges between 0 to 1, where if you have a 0, it indicates that there is hardly any diversity at all. And the closer you get to 1, the most diverse your group will be. Okay. So 0 to 1, 0, hardly any diversity. It's almost all the same. 1 is closest to most diverse. Now we have this lovely handy dandy slide. Okay, now be prepared, guys. The next slide, I plug in the numbers. It's going to look messy. We're going to go through it and it'll be a-okay. Take a deep breath. Here it is. All right, so here is the IQV for each state. So here's my formula again, and here's how I would compute. Did I say 5 and I was 4 this whole time? You guys have been very kind to me if I made that stupid error. Oh, maybe they counted only 4 categories here for Maine because they didn't have any Native Hawaiian or Pacific Islanders. That's what they did. Okay, you guys all see that? Okay, so Maine only had 4 categories. Hawaii had 5. Okay, So my K for Maine is 4. Then I do my 100 squared. Oh, looks like a few people got kicked out. 100 squared minus my sum of squared percentages for that category, divided by 100 squared times the category minus 1. That gives me an index of qualitative variance of 0.07. What does that tell us?
There's little variation.
There's very little variation. Yes. Now, here's my beef with the IQV. Okay. Watch out. I'm going to skip slides again. Oh, that's not going to work. Just kidding. Okay. Even looking at this one, could you have figured it out by the frequency? What do we think? This number seems awfully high to me, right? That's a pretty homogeneous sample right here. If you're looking at one group has 97%, that leaves you with about 1% for any other category. That is not shocking to me that Maine is not diverse, okay? So I can go through all the calculations like we did here, but this number is not gonna surprise me. Okay, now if I go through it for this other one for Hawaii, I run through the same numbers. So 5 categories of ethnic diversity. Excuse me, I do 100 squared minus my sum of total percentage squared for that category, divided by 100 squared times the number of categories, which is 5 minus 1. That gives me an index of qualitative variation of 0.84. What does that tell me? What do you think, Aaron? I'm seeing you shaking your head.
I'm just like looking at it. I'm like, I know it's a lot higher than the 0.7%, but I'm not sure if that would be considered like a big difference or if it would be still be like relatively small since it's still only like 0.84%.
So it's an excellent point. If you're like, I don't know, 0.84, it's more than the other one, and probably eyeballing the frequency, you could have come to that same conclusion. Actually, even without seeing any number, someone said, which state is most diverse, Maine or Hawaii? I think most of us might have just inherently said, probably Hawaii, seems a bit more diverse, just, guessing. So the points though, the IQV ranges between 0 and 1. So 0.84 is really approaching 1, and 1 being as diverse as you could possibly be, right? Meaning each category would have an even split. So this is actually pretty diverse. This is pretty diverse, right? It's approaching 1. Thanks for being a good sport and let me pick on you there. All right. So to summarize, these are the steps that we follow to calculate the IQV. You construct a percentage distribution, which we all know how to do, right? If you know the total n size, like your total sample size, and you know each frequency for each category, you can figure out a percentage. That's easy peasy. Then you square the percentages for each category, sum them, and then calculate the IQV using the formula that's right here. Okay, that is how we do that. Here is another one. So if you guys wanted to have fun with this and test it out, these are the percentage makeup of population by region, or for regions by race. So we've got the 4 regions and then the different racial groups that are identified here. And then you see the IQV has already been calculated. What conclusion might you draw from the following IQVs?
The West has the highest variation However, the South, like is relatively, relatively has like a high variation in comparison. And then the
Okay.
lowest would be in the Midwest.
We get to represent folks, well, here in the Midwest, not super diverse. Absolutely. So the most diverse region is the West. Taking seconds would be the South, and the least diverse is the Midwest. Okay. All right. So that's the IQV. Next, we'll talk about the range. The range is a measure of variation for interval ratio variables. So the other one, the IQV, that's for nominal variables, right? Something like race. We can't assign a number to that. Range is for interval ratio variables where the difference is between the highest and the lowest score within a distribution. Okay, that is the range. You could calculate that really for percentages. You could do it for scores on an exam. It's really just a crude measure that allows you to see the highest and the lowest score so that you can take like an eyeball snapshot, a quick snapshot of how much your data varies. Okay, but we need to be mindful of this because it could include outliers. It might make the range seem misleading. It might seem higher because you only have one data point. So again, in my example with graduate school age, maybe the range is 72 to 24 or 23, but maybe there's only one 72-year-old and everybody else is clumped in the 20s, right? That could be an outlier. So then my range could be misleading because of it. It's not an actual measure of variability, spread, or dispersion in your distribution. Okay. Now we're approaching more accurate measures. So the interquartile range is a measure of variation for interval ratio data. It shows you again the width of the middle 50% of your distribution. And it's defined as the difference between the lower and upper quartile. So quartiles, percentiles, those are often words you'll hear, especially in child development. If you think about how fast your kid is growing or how tall they are, oftentimes those will be reported as percentiles, but it can also be reported as quartile. It's really the idea that you're taking that middle 50%, or you're dividing your entire distribution in fours so that you end up with quartiles. And then the middle 50 is kind of your average or your measure of central tendency. And everything else is it's in the tails, right? So your interquartile range is your third quartile minus your first quartile. In other words, it's your 75th percentile minus your 25th percentile. And that's how you end up with your interquartile range. Okay. So these are the range versus the interquartile. You see the two difference here. So what you can see, if these values, they're all together right here, they're clumped together, right? But then you have these two that received a 10. So this is like how many kids are in your family. So there's two individuals that said they had 10 kids in their family, but everybody else is really clustered around 1, 2, and 3. If you look at this, the range is actually the same, right? The range is your highest versus your lowest. So that's a range of 10. And this one is a range of 10. But you see how the distributions are actually quite different? Hopefully you guys all see that, right? So the way you would figure out your quartiles is you go through and you figure out your midpoint, and then where is your 25th percentile and where is your 75th percentile, and you minus those two. So your 75th percentile here is 3, 25th is 1, 3 minus 1 is 2. That's a very small interquartile range, which shows that's really clustered together. This is a more diverse or dispersed distribution. And so you see your 25th percentile, that first quartile right here, is at a score of 1, whereas the 75th percentile, your third quartile, is at a score of 6. So 6 minus 1 equals 5, interquartile range of 5. that shows far greater variation within your distribution. Okay. Does that make sense? Okay. Just so you know, I'm not a huge fan of most of these. Standard deviation is where it's at. So that's what I'll be testing you guys on the most. Okay, a box plot is a visual representation of all of the things we've just talked about. So it'll include your range, it'll include your interquartile ratio, it'll include a median, the quartiles, the minimum, and the maximum. So it'll do a range with it, okay? All right, so this is what it looks like. And you guys have likely seen this maybe, and you know, as you guys are perusing, you know, academic journals, as one does on a Saturday morning with a cup of espresso. Yes, this is what it looks like. So it highlights your median. Your median is going to be the line in the middle of your box plot. Your box is made up at the bottom with quartile 1. The top line is quartile 3. And then you have the whiskers here is what they're called, which shows your maximum range and your minimum range. Now, you will likely never see a box plot that looks identical to that because this is like perfectly equal. What you're more likely to see is something like this, okay? So this here is showing your maximum, your minimum, and see how it's like more squished and stacked, okay? And this shows here for a skewed distribution. It really highlights it pretty well with the whiskers here when you have a score that's way out in the middle of nowhere, right? An outlier that's sticking out. It allows you to see that a bit better. So the goal of the box plot is a just quick visual representation. So that's, again, what you're going for. I'm not going to have you guys construct box plots in this class, especially online. That seems like that'd be testing your graphic design skills, which if I don't have them, I don't expect you to have them. It's beyond the scope. Okay. You guys get me after I've been teaching so many classes and I'm always so thirsty. So I apologize, I'm like guzzling down water. Sometimes I even have Pepsi to give me a little pep in my talk. Anyway, variance. Variance is a measure of variation for interval ratio variables as well. The way we calculate variance is we're approaching standard deviation here. It is the average of the squared deviations from the mean, okay? So the average of the squared deviation from the mean. So it tells us on average how much the individual score deviates from the mean. It's based on all of the scores, just like the interquartile ratio. Excuse me. Okay, so let's look at an example. So I just described that, but the way you do the steps to actually calculate variance is you subtract the mean from each score, square each of these deviation scores, add up the squared deviation scores, and then divide the sum of squared deviation by the number of score. This is when I try to describe a formula, when really the easiest thing might be to just do this. This is what it looks like, okay? This is your formula for variance. It is the sum of an individual score minus the mean, right? Like the mean is shown with a bar on top, squared. And then it is divided by the sample size, the number of scores, minus 1. Okay. Again, you guys don't need to memorize formulas in this class because you have access to our slides at all times, but this is how you compute it. Okay, so in order to do that, I think it would be beneficial for us to do it as a class and practice it a little bit. So here's the steps we're going to take. We're going to first calculate the mean of a distribution, okay? And we calculate a mean by adding up all of our scores and dividing it by the total number of scores in our sample, okay? Then we're going to subtract the mean from each score to find the deviation. Next, we are going to square each deviation and sum the squared deviation. Lastly, we're going to divide the sum by the sample size minus 1, and that answer is our variance. Okay, that's a lot of talking. Now let's put pen to paper here and practice it so that it can start making sense. Okay, I'm opening a new sheet and then I'm just going to share it with you in a second. I'm creating a distribution as we speak. These are scores for students on an exam that was out of 25. Let's see, 3, let's do a few more. Okay. Let's do one more. Okay, let me share this with you. All right. Is everybody seeing my row of numbers? Yes. Thank you. All right. So what is my first step? What do I need to do? And here's what I'll do. I'm going to copy this real quick. Did you guys get those numbers in chat? Okay. This way you can do it at home also. Okay. What's my first step? I have this data. I want to know how much this distribution vary. What is my first step? What do I need to calculate?
The
mean.
average.
The mean. So how do I do that?
You add them all up and like divide by the number of like that are in the list.
Very good. Okay, so how many numbers are in my list? So, or in other words, what is my N?
$32.
So 32, yes, except I have these two little empty columns. So that would be then 32 minus 2.
30.
30.
30. Okay. So take a moment and add up these numbers. I'm going to do it here as well. Okay. How are we doing? Okay, what was your total score? Anybody?
Just a second.
Sure. Well, it doesn't have to be you either, Aaron. You're certainly pulling a lot of the weight. What do we think?
I don't know if I did this right, but I got 526.
That is also what I got. Let's see if anybody else. 526 from Lainey.
Me
Okay,
too.
good. Yay!
Same.
Yeah.
526. So then I've added them all up. How do I figure out my mean?
Divide by the number of numbers.
By the number of scores. Excellent. And what is that?
I don't think,
17.5.
yeah, that's what I got too.
17.5?
Yeah.
17.53, but we'll just round to 17.5. Whoops, somehow it's not writing in the right spot. Okay, so now I have my mean, which, oh, this is bugging me. There we go. And I have my total number. I'm going to need both of these things. In order to calculate the variance, what is the first thing I need to do?
Subtract each score by the mean.
Yes. Okay. And I will tell you, whenever I calculate the variance or the standard deviation by hand, I always do it in a spreadsheet. And I'm about to teach you why, because we can do a little, I mean, you can actually write it out in columns on pen and paper, but I find a spreadsheet works even better. So this is going to be, I'm going to title it at the top. It's going to be my score minus the mean. Okay. This is what this column is going to be. So I'm going to open up a formula. Now, just quickly, if you are using Excel, just FYI, Aaron, you're not muted. If you want to know your mean and you want to do, that's okay. You want to do a quick cheat sheet, you can highlight all these numbers. Okay. You guys see that? It just gives it to you at the bottom, gives you the count, gives you the sum. And that's when you're like, she is mean. She made us add it up with our phones. But it's a good practice to have because you may not have Excel in front of you. So, okay. This is a good way to double check we did it right. Yay. Okay. So we are now going to do a formula. In Excel, you start a formula by pressing the equal sign. You are going to open up your parenthesis, and I'm going to do my score. I'm going to select it, which is 12 in this case. Then I'm going to do minus the mean. And I'm going to close the parenthesis. Okay. And that's going to give me negative 5.5. Okay.
Sorry, could you do that again?
Yeah, let's do it with this next number. So now my score here is 19, right? So I'm going to come over here and I'm going to open up a formula. So I'm going to start by doing equal. That's how I tell Excel, oh, she's doing a formula. Even more so, I open a parenthesis. Now I'm selecting the score. See how I populated C4? So it says whatever's in the cell, and I'm going to do minus my mean, which I know is 17.5. And I'm going to close my parenthesis. Okay, then I press enter, and that gives me 1.5. Did that help? I'm not sure who had asked the question. I want to make sure that makes sense.
I was trying to figure out as you were doing it, and then I got like lost halfway through, but I got it.
I know.
now.
I feel like I would do that too. I'm like writing. I'm like, wait, she's 5 steps further. And this is why we are recording this, right? Oh, golly, I hope we are. Yes, we are. Okay. All right. Now I could go through and do this for every single cell. Or I could utilize the computer's superpowers, which is to highlight these two. So these two have the formula in it already. Now, gang, I have to be honest, and Hannah or Grace, I think it was Grace earlier, I know nothing about numbers. So I am ill-equipped to show you the wizardry that it offers. I do not know. I do know Excel though, and it is fabulous. So I highlight these two, and you guys see this little green, gray, maybe, I don't know, square at the bottom right-hand side. I'm going to grab that square. That sounded dirty. I'm just going to take it, and you see the X sign? I'm going to drag it all the way down to my last row. Now you guys ready for the magic? I'm gonna let it go. Boom. Okay. So what it did is it figured out, oh, you're doing a formula. And the formula is always the same. You are grabbing the number from the cell next to it, and you're doing minus this number that's static. It's always minus 17.5. So you did that twice. Now I'm going to copy it and do it for every single one of those. Okay. Make sense? Pretty easy. Okay. What is the next step?
To square each deviation.
Okay, now let me push you guys a little bit. Why do you think we need to do that?
Because if you add them up now, they'll equal 0.
Okay, because we have some negative values, right? So if you think about it, like just conceptually, right? You have your mean. Some of those numbers are going to be above it. Some of them are going to be below it. That's the whole point. A measure of central tendency picks the midpoint. So by default, some of them are going to be higher, some are going to be lower. If I add all of these up, Diana is absolutely correct. That will add up 0. In fact, let's test it. If I add all these guys up, oh, now this is saying my sum is 1. Did I do something wrong? I feel like it should be 0. The average is 0. We're going to just leave it be right now. Okay. We're not going to poke at the bear too much. But another reason why we do it, I'm going to do squared. There we go. Is because I don't want any negative values in there, right? I want the negatives to go away. Okay. So the way I'm going to do that is I am going to do another formula, equal, open parenthesis, and I'm going to select this cell. I'm going to do the multiplication and times it by itself. There we go. Click it again and close it. Okay, show you guys again. You do equal, open parenthesis. I'm going to select the cell, multiply by itself, because that's what squared is, right? Okay, now I'm going to do the same trick. I'm going to drag the formula all the way down. And here's what I get. All right, am I done? What do I need to do next?
Do you have to divide the sum of that?
We do need to do that, but we have to do one more thing right before we do that.
Square them.
We squared them, yep.
The deviation. Okay.
Sum the squared deviations.
Yes, you have to sum these. Okay. Now, a couple different ways I can do sum. I can add up one after the other. I could just highlight it. That shows me the sum is 629.5. Or I could also go up here. Do you guys see auto sum? Top right-hand corner. I could click that. It automatically highlights everything in here. Press enter, 629.5. Okay, what's next?
Now we can divide the sum.
That's right. And what do we divide it by?
30, right?
Close.
30 minus 1.
Yes, it's the n minus 1. So my variance equals, and I'm going to actually do that. Open my formula. It's this number divided by, what's n minus 1?
29.
29. that gives me a variance of 21.7. Which is not right. Something is not right here because it is not, should not be varying that much. Oh, that's why. That's why. Yes, it's good. It's good. That's the variance. I'm thinking that's not the standard deviation because we would need to square root that, but we're not there yet. This is just variance. Okay. Does it make sense how we walk through all of that? So on an exam or a quiz, you would be given a much smaller data set to deal with. On an exam, maybe this big, and you would need to show me these exact steps, how you went from, and here's the reason why, not because I want to micromanage how you did it, but because if you make an error, I can spot where it went wrong, and then you lose fewer points. Okay. That is how you calculate the variance. Now I need to go back here. Here it is. Okay. So this is exactly what we just walked through with a specific example. All right, now to visualize this variance, let's look at these different distributions, okay? All of them in this row A have the same mean, right? Like they're all at 3.2. But note how different they are. So here, this is a mostly normal distribution, right? Where your mean is the highest level of frequency, right? It's normally distributed. Here, this would be considered a bimodal distribution, which means here's the mean, but you would actually have two modes. And then this would be a negatively skewed distribution, where most of your scores are further down the tail. Okay. Now we are looking at different means. So the means are not the same, but it's the same level of spread, meaning the distributions vary similarly in terms of range. Okay. So huge impact on distributions. Here's two more examples. So these are two distributions with the same mean again. Here's our mean, but a different amount of spread. Okay. You can see this one is pretty tight knit together. Most responses are right around the mean. And the other one here, much wider. Okay. This is housing price for neighborhoods with diverse types of housing for neighborhoods with consistent type of housing. Okay. So if all the homes are single family homes around 3 to 4 bedrooms, the prices are kind of similar, right? They're all going to be clumped together. There's not going to be a whole lot of variability. But here, if I'm in a neighborhood that has some smaller condos, some smaller fixer-upper homes, and some mega mansion, you're going to see the housing price is far more diverse. The mean may be the same, but the variance or the distribution of your sample is going to vary quite a bit. Okay, does that make sense, gang? I want to make sure that we're all okay on the same page. All right, let's talk about the standard deviation. This is your gold standard measure for variation for interval ratio variables. Whenever you see an academic paper that's written, they always comment on the mean and the standard deviation. Those are the two that are most common. It is on average how much scores differ from the mean in either direction. But we need to make sure we understand the standard deviation does not describe the shape of the distribution. It only gives you a numerical value that, you know, shows you how far away from the mean most scores fall. Okay. Here's some possible distributions for family size in a country where the mean is 4 and the standard deviation is 1. Okay. So family size, the mean is 4, right? Presumably 2 adults, 2 kiddos. Standard deviation is 1. So you see in that first table here, you just have like 2 really smaller groups on either end. But here, this is a very different distribution, right? You see most people have 4 members in their families, but then a much higher number have 5 compared to 1. Okay. Here, this is interesting. Again, your mean is 4, but there's not a single finding of a family with 4 family members. They either have 3 or they have 5. So again, your mean and your standard deviation are the same in all 4 of those cases, and yet the distribution is significantly different. So again, standard deviation and mean cannot tell you about the shape of the distribution. Okay. So variance, as I was mentioning, is very rarely reported in journal articles. Most often is the standard deviation. It is the most common way to describe the spread of a group of scores. Okay. Now, the good news is we did all the hard work, because the way you get to standard deviation is you calculate your variance and then you just take your square root of that value. All right. Unlike the variance, the standard deviation is in the same unit as the individual score. In a normal distribution, 34% of scores fall 1 standard deviation below and 1 standard deviation above the mean. So this is important. I want to just take a moment here and draw that out. Okay, so if you have a normal distribution, pardon my bad drawing. Can you guys see this in red? Okay, so right around here would be your mean, right? Shoop. What this is saying is if I were to draw a line right through here, oh boy, this is the Michigan line, you're avoiding the potholes. All right, this section, okay, now to test out whether you understood what it meant. What percentage of the distribution falls right here? If this is a standard deviation 1 and this is standard deviation -1.
For mean to the first standard deviation, it would be 34%. But if you were to consider like -1 to 1, then it would be 68%.
Very good. Okay, so 34% is between the mean and 1 standard deviation above the mean. Okay, 34% of scores are there. Interestingly, this section also 34%. So what Diana was saying is that 68% of scores are within 1 standard deviation away from the mean. Okay, flipping it on its head. If you scored higher than 1 standard deviation away from the mean, let's say you're like, this is me. This is Dr. W's test score on something, okay? Here's a way that I could figure out where I fall, okay? If I know that 68% of the population scores between 1 standard deviation of the mean on either end, what does that leave me with? Okay, not trying to do complex math here, but if 68% is in here, what is left over in either of these tails? Let's see if I can switch color here. I can. Oh, this is starting to be my favorite thing. In here and in here would be 100 minus the 68, right? Because my entire curve is 100%. So if I know this middle section is 68, then how much is in the tails? I do 100 minus 68, which gives me 32. Is that the answer? 32 is both sides. It's these 2 sections. So if I want to know just this top side, I need to do that divided by 2, which gives me 16. Which means these 2 sides are each 16%. Maybe at this point you're like, well, why do we care about that? Well, it's all about perspective, right? So if you know you scored above 1 standard deviation above the mean, then you know you're in the top 16%. Big asterisk, provided it's a normal curve. Okay? Questions about that? As we go through this class, we will talk about this normal curve and it'll become more and more subdivided. So you'll talk about the 1 percentile. We'll go through it. But this is just good eyeball value so that you guys know what does it look like. So if you get a random score and you know what the mean is and you know they're above 1 standard deviation of the mean, you can speak to their placement within the distribution. Okay, it's real quiet. I don't know if people are like, what did she just do? Taking it a quick step back. Is everybody on the same page for this stuff right here? So we figured out how to calculate the variance. To get the standard deviation, all you need to do is take the square root of that variance. Okay, so here's the calculation for it. Honestly, we had done all of this already. We just did not have the square root around it. That is the only difference. So I'm going to pause this for a second and we're going to share this again. Okay. So we know here, you guys see the Excel spreadsheet?
Yeah.
All right. So now I want to know my my standard deviation. I'm just going to do that. But OCD me, we need to have, okay, better. All right, so the way I'm going to do that is I want to do a square root. Lovely Excel can do it all. So I start this, I open my parenthesis, and now I'm going to start writing square root. So you see I pressed S and there's all these formulas that populated. I need to find square root. It was right here. Returns the square root of a number. I'm going to click that. I'm going to highlight this number up here. And then I'm going to close both parentheses. Okay, notice that? There's a parenthesis for the score and a parenthesis for square root. So my standard deviation is 4.66, let's say. If you wanted to go more old school, you could use your phone, your calculator or your phone, and then type in the square root of that variance number. You should get the exact same value. Questions on that? Does that make sense?
Yes.
Okay. So you will need to do this for quizzes and exams. So I want to make sure that that's clear. So the process is, with any distribution, first things first, you get your mean and you identify what is your sample size or your N. Next, you take away each score from the mean. Next, you square that difference. Next, you sum it all up. And then if you're getting your standard deviation, you just square root it. Okay. I'm going to stop this one and we're going to go back to our lecture, which is right here. Okay. So this is, again, this is the formula for the standard deviation. Same thing as variance, just square rooted. All right. So the deviation from the mean is, again, figuring out where is that mean, figuring out each score and how much they differ from that mean. What is the difference, again, between it? Okay. If you see here, the difference, the standard deviations all add up to 0 as well, because it all centers back to the mean. Okay, so this is back the projected percentage change in the elderly population. You see by region, this is the percentage of change. Okay, this is the sum of my percentages. Then I can do the, okay, so right, you sum this, even though the percentages, then you divide it by your N, which is 4 regions. That gives you the mean. Okay, this is what the number is here. That's the mean, 19.95. Then I take each value minus the mean, right? That gives me this lovely value. but then I need to take it further, right? We'll talk. This is again, the same calculations we just did, just adding the next ones over. I'm not sure that I actually included the next calculation, but you guys know, what would we do next? Right here. We would square it, and then we would add up the sum of squares, and then we would square root it to get the standard deviation. Okay. So this is how we could illustrate the means and standard deviation. Okay, this is the average age for specific jobs. So this is in a clerical environment, and this is in a technical environment. My cat might jump. She's behind me right now. She's a little frisky. You guys are like, how many pets do you have in your house? The answer is 3. We have 3 and 4 kids. Life's just always busy. Okay, so in a clerical environment, the mean age is what?
39.46.
That's right. That is the average age, 39.46. The standard deviation as listed here is 7.0 or 80. I can read. In a technical type job, the mean is 39.87. Again, actually quite similar. But look at the standard deviation. It is much smaller. So that means if you're in a technical position as a woman for this particular sample, you're clustered more closely together in age than in a clerical position, where you can see you have some representation for folks who are a lot younger, and maybe some that are about, you know, it looks like it taps out of the same ceiling, but just mostly younger. Okay. So again, very similar means, standard deviation differs. Okay. This is how you will see them reported in research articles. You will have your mean and standard deviation noted this way. It's a capital M, capital SD, and then their own column after that. So you see it's subdivided for women and for men, and then it goes down. Okay. Again, it's describing the data. It's describing the sample that you have. This way, your reader or your audience can get a quick look at how scores are distributed in your sample. Okay. When you are choosing a measure of variability, it's important to keep in track what type of variable you have. If you have nominal variable, like at people's ethnicity, their religious preference, their political affiliation, you can only use the index of qualitative variance. That's all you can use. Okay. If you have ordinal variables, you can use either one, the index of qualitative variance, or you could do the interquartile ratio. If you have interval ratio variables, though, the gold standard, I mean, I know it says you can use all of them, but the gold standard is using standard deviation. Okay. Standard error is what we'll talk about in a few weeks as well. But that's the most common. Okay. That is variance. Questions, comments, concerns, confusion. How can I help?
Well, maybe just to refresh us, could you go back to the Excel sheet and show us how to do the tables again?
Yes. Okay, let me close this. All right. Whoops. Where did you all go? Okay, hold on. Keep. Nope. Nope. Here you are. Okay. All right, let me share this. All right. We gotta come up with some scores again. You guys ready? This is how random my brain works. This is probably not random at all, actually. I need one more. Okay. So what is the first step? What do I need to do with this distribution?
Add them all up.
Add them all up. All right. So my sum, and I can do this, auto sum, 2267. I'll do that. What is my n?
30.
30, right? It's the same number as before. I kind of kept it simple. All right. So then my mean is what?
$17.5 again? Or no, just kidding.
So it'll be this total number divided by 30. So, I mean, I could, let's see here. Let's do it. This number divided by 30. 75.57 or so. Is that what people got?
Yeah, I got that.
Okay. My next step is figuring out the difference between each score minus the mean. Okay, so I start off and I need to teach the computer what is going to be my formula. So it is, I start by pressing equal, open parenthesis. I click on the score, which is 60, minus my mean, which is 75, whoops, 75.5, we'll just say 0.56. Yeah, that's fine. And then close her up, okay? So for that one, it's negative 15.56. I'll do one more for good measure. Equal, open parenthesis, I select my score, which is 66, minus my mean, which is 75.56. I close the parenthesis. That gives me negative 9.56. Now I want to know, I'm smart. I'm going to use my shortcuts. I'm going to grab, I highlight these two cells. You see the little square here. I line up my cursor with it. It makes a plus sign. I press down and I drag it all the way down. Okay. And that populates all of these scores. Next, I need to do the score minus the mean squared. So I'm going to teach the formula again. So it is equal, open parenthesis. I select my score, multiply it by itself, close the parenthesis. Here's that score. I do it one more time. Equal, open parenthesis, select my score, multiply it by itself, close parenthesis, enter. Okay, so now we've populated the formula. I highlight these two cells, move my cursor over the little square till I see a plus sign. I click on it and I drag it all the way down. And it populates all of it. Okay, am I going too fast? Is this making sense? We good? Okay.
You good?
So next, I need to calculate the sum of all those square differences. The best way to do that is to go up to auto sum. Here it is, and I press enter. Here's my total. Okay. Now I know that is, that's my total score. What do I need to do next? I can't just leave it like that. That's not my variance. I need to do one more step to get variance.
It's the square root now, right?
That's to get to my standard deviation. You're absolutely right. But to get variance first, I need to divide it by something.
Would it be 29? Because it's the n minus 1, but n's 30.
Exactly. So my formula, so I'm doing equal, open parenthesis, I grab my total score, and I'm going to do divided by 29 because it's n minus 1. Okay, here it is. That gives me a variance of 177.15. Now to get to my standard deviation, it's going to keep bugging me. I like me. There we go. Okay. What do I need to do next? I need to square root, just like Aaron was saying. So I press equal and I start writing SQ for square root. And the very first one that pops up says returns the square root of a number. So I'm going to double click that. I'm going to put in my number. I'm going to close the parenthesis, press enter. That gives me a square root of 13.31. So 30. So that means, sorry, guess it's getting late for this one. My mean is 75.56. That's where the average score lies with a standard deviation of 13.3. Okay, now let's take it to the next level because you guys are able to do that. If I wanted to know where does 68% of scores fall, it would be a range. What would that range be? So if I know that 68% of the score, presuming this is a normal distribution, okay? If they fall between one standard deviation of the mean on either side, okay? And I want to know what is that actual range, I could calculate, again, a formula for it. So first I would want to figure out what's my top range, which I would do my mean, which is 75.56, plus my standard deviation. And then I would need to figure out my bottom range, which is my mean minus the standard deviation. Whoops. Okay. So 68% of scores fall between 62.25 and 88.87. And I figured that out because it is plus or minus 1 standard deviation from the mean. Oh boy, it's not liking that, but. It's probably not gonna like it if I try to go anywhere else on the page. No, no, no. Let's see if I could just do that. Okay. I tricked it. Okay, is that making sense? So this is how fun stats can be. You get to manipulate all the numbers and try to make sense of it. Because again, what does it mean? Oh, okay, mean standard deviation. What do I care? Well, now if I pick a random score like this 91 over here, I have a lot more data, right? I know that that score is more than 1 standard deviation away from the mean. So that student scored in the top 16% of their class, right? Then if I see this score, I'm like, oh, he's like, no, the professor was real hard. Everybody failed. And you go, you're lying. No, the mean was 75. Mean was a C. Standard deviation was 13. So even if you were standard deviation below, you would have gotten a D and you got an F, right? Not that you have talks like that with anybody because all your friends probably get an A's, but okay. So we can do more of these next week if that would be helpful. I find when we do a ton of math, I start getting these glazed over like, oh gosh. The goal for you guys is to complete the lab. Just go through the same way that I did the pivot tables and then copy over each table with 2 to 3 sentences of interpretation. Make sure that you do that for qual and sex and then do qual and race. So there should be 2 separate analysis. You need to make sure that those, your lab, that document is submitted by the start of class next week. Okay, so you have a whole week to complete it. Honestly, shouldn't take more than 30 minutes would be my assumption there. Not too long. If you're like, I've been working at it for 2 hours, shoot me a text or email me because you've probably jumped off the deep end and I want to help rescue you and send you that buoy over. Okay. Any lasting question? Are we good? Doing all right? Okay. Practice it. Review this video if you have any other questions, and then we'll see you all next week. All right.
Thank
Happy Wednesday, everyone.
I have to ask you a quick question.
Sure.
It's not related to class, really.
Okay, then let me stop the recording.
Okay. So I have